Hi, I'm Miloni Bhatt, and welcome to this special workshop part of ET Career Ready, a platform that sets you up to learn from the best in the industry. And our focus today is on the growing electric vehicles industry. The Economic Survey 2023 predicts that India's domestic electric vehicle market will see a 49% compound annual growth rate between 2022 and 2030. Annual sales will touch up to 10 million, and the electric vehicles industry is projected to create around 50 million direct and indirect jobs by 2030. EVs obviously are a huge opportunity. And today we have with us Vatsal Shah, an associate director at Skill-Lync, to take us through the trends of the EV industry and the career roadmap for students keen on pursuing a career in this sector. Not just this, Vatsal will take us through a case study on Tesla, one of the top EV companies led by billionaire Elon Musk. He'll dive into how Tesla disrupted the space and grew it into a profitable business. But first, a little bit about Vatsal. He is the Associate Director of the Electric Vehicles domain at Skill-Lync. He has 14 years of experience in academia and industry. He graduated from the Nirma Institute of Technology with a master's in power electronics and drives.
Hi, everyone. Good evening. Thanks a lot, Miloni, for introducing myself. In this session, we are going to talk about electric vehicle technology and the interesting story of Tesla. Before I begin, I would like to ask a very basic question. So let's say if you go back to past and take a look at your grandfather's vehicle or take a look at the first vehicle of your father, right? And now you come back to the present moment and see what kind of vehicles are available in showroom, right? Be it a two-wheeler, three-wheeler, or a four-wheeler. What are the changes that you see nowadays in the vehicles? So automobiles have changed a lot, and there have been a technological revolution in terms of design aspects, in terms of aesthetics, in terms of how it looks and feels, in terms of the comfort it can provide, right? So apart from this all, right, the fundamental technology which moves the vehicle, which is usually known as a propulsion unit or the powertrain of the vehicle, that has also gone a tremendous change. So the engine that you were able to see earlier and what you have nowadays, it's a complete change, right? So now you have a lot of digital control, a lot of data coming out of engine, a lot of sensors added to it, and electric is the next thing which is coming into existence. And even for India nowadays, you can see a lot of electric vehicles. So what is the story of Tesla as a startup, how it became successful, and what you need to understand in nutshell about the EV technology? That's what I'm going to cover today. So let's get started. I'm going to share my screen and we'll discuss about the interesting story of Tesla Motors. So once again, welcome you all. On behalf of Skill-Lync and Economic Times, I welcome you all to this session and let's get started. So this session is for all EV enthusiasts. If you are a newbie, right, let's say you do not know anything about electric vehicles and Tesla at all, that's totally fine. And if you are curious to learn more about how Tesla became successful, and even though if you are already following Tesla, right, or if you have heard a lot of things about Tesla, then also you are going to get a deep dive into the technical aspects. So what are the vehicle specifications, how you can get started learning about EV, right? So that's all we are going to cover in this session today. So here, let's say when you have heard the word Tesla, right, it's actually one of the unit, right? So you might have heard, if you are an electrical engineering background, you might have heard voltage, ampere, right, Weber, Tesla. So these are all name of the scientists, right? And probably Nikola Tesla was one of the great scientists, and I'm quite sure you must have heard of it. But Tesla is a company, right? Or Tesla is a disruption making company in this space, right? What it was capable of doing and what is the story behind it, right? And how you can get started learning about it. That's what is the agenda for today. So let me briefly discuss what are the things that I'm going to cover today. So first, I'm going to speak about how did EV come to the existence. And there were a lot of struggle. Obviously, the IC engine took over and it was a winner in past. And then what is the rebirth of the electric vehicle? What happened so that the EV came to existence again? And then I'm going to talk about more on where are we now? So what is the state of the art currently? And what are the future predictions? And then we will have a closer look at the EV technology. And we will also see Tesla business plan and what is the technology in the vehicle that they are using. And we are going to also cover how do I get started, right? So if you are a beginner level person, what you need to get started with, right? So you need to have a physical system knowledge. You need to know mathematical modeling and what are the simulation tools that you can get started with. And I will also cover what is happening in India for electric vehicles, right? So how Indian automotive industry is following the trend, right? So that is also part of the agenda. So let's get started with the very simple definition of an electric vehicle. So the vehicle which uses the electrical energy stored in the battery to move from one place to another, right? So this is the most layman's language for an electric vehicle. So basically, the wheels are rotated with the help of motor, and the motor receives power from the battery. So this is the most simple definition. Electric vehicle is the vehicle where there are no engine, right? And you have two major components. One is the battery and another is a motor. And that's how the vehicle moves, right? And there are various category of the vehicle based on the source of energy. You all must be aware of this. So let's say spark ignition engine, let's say where the fuel is petrol, or the compression ignition engine, right? The diesel or the CNG, right? So these are various categories of the vehicle which are listed over here. And electric and the hybrid electric is of our interest for this session. So what happened to early efforts of electric vehicle? So the image that you are able to see on the right side is the very first electric vehicle. And maybe it was 1830 at the time where people thought about converting a bicycle into an electric one, right? Or a single passenger small electric vehicle. So what actually happened to the early efforts? So it's not just about having a battery in place. Let's say there is a battery and there is a motor. You connect these two together, and that's all. Your EV is ready. So it's not all about having the powerful motors or having a battery, but it's all about how the combination of the two is feasible for automotive application, right? So whether do we have a motor which is actually applicable to electric vehicle? Do we have the motor? Do we have the battery as well, which is equally useful for the vehicles, right? And powerful motors were existing at that time, right? So no doubt the electrical technology that got developed, and there were a lot of electrical motors, AC motors and DC motors were existing. The battery was also existing. Uh, Obviously, the rechargeable battery was not invented at that time, but power density of the battery was a bigger challenge at the time. And that's the reason why internal combustion engine vehicle became the better performance before the electric vehicle. And it's not just about vehicles, right? So when you see the complete transportation system revolution, you need to understand how the roads were also developed, right? So let's say, what is the road infrastructure at that time? So the road infrastructure became very, very uh, evolved, right? And it was kind of a road infrastructure that the long distance travel was the need. And that's where the electric vehicles failed. And due to the power density of the battery, right? So if you want to run a vehicle more than 20 kilometers, more than 25 kilometers, you need to have a very heavy battery, which is occupying a lot of volume, where you don't get any space to sit, right? And that was the challenge. So that's the reason why for long distance journey, internal combustion engine became a better performance vehicle because more energy was contained in the petrol and diesel than the energy which is contained in the uh, battery of the electric vehicle. So let me take you through the timeline of what happens to the early efforts. So what you see now over here, right? So the first ever experiments of the motorized vehicle uh, was done with the primary battery cells. So the primary battery cells are the cell which cannot be recharged, right? So it's just one battery and it's use and throw, right? It's similar to the cells which you use nowadays for the television remote control, right? They are not rechargeable. So the non-rechargeable electric vehicles were the first ever experiments in the year 1830. Soon after that, 50 years, the rechargeable battery was invented, and the lead acid battery was the first version of the rechargeable one. But it was constrained with the power density. So the amount of power it can store within a given volume was a bigger challenge. Now, at the same time, if you look at the motorized vehicle, right, where there is no need for a battery, right, where you receive the continuous electrical supply from a wire, right, from the overhead cables, or let's say the transmission system, right, then that type of a transportation became successful even in 1880. And that's where the railways became electrified, right? So non-rechargeable battery, or I will say no batteries at all, but still you can run the vehicle on electricity. That became very popular since 1880. And that was an era where electric traction for railway became successful. Now, coming to the third phase over here. So various manufacturers started building the electric vehicles in high volume in the year 1990 to 1900 to 1990. So Sinclair C5 was one of the tricycle which actually failed due to the limited range and less comfort compared to other vehicles. Detroit Electric was one such company. They manufactured more than 13,000 vehicles. And at that time, electric vehicles were actually underperforming. So when it comes to the range, when it comes to, let's say, the top speed, when it comes to the number of passengers that can uh, be accommodated, or uh, let's say it's the amount of acceleration that you get, right? So the top speed, acceleration, range, everything was compromised because of the technological constraints, and various manufacturers tried during this era, but they failed. Now, the year 1991 to 2010 is considered as a rebirth of the electric vehicle technology. Now, EV came into existence because of the revival of interest of the customers. So there were more customers or more number of people who are interested in what happened to EV and the battery operated vehicles. So now was the time in 2003 to 2008 was the time where automakers started focusing more on high performance vehicles which are with better motor and the battery. One such great example is General Motors EV1. In 1996, they came up with GM EV1, and that was one of the high performance vehicles. Honda and Toyota also launched their first EV during this time, and Tesla came up with their first ever vehicle called Roadster in the year 2008. And 2011 till date, EVs are now becoming mainstream, and there are more than one supplier. There are a lot of engineers who have started working on electric vehicle technology, and now you can see even in India, you can see a lot of vehicles are electric. And if you are, let's say, in a mega city like maybe Pune, Bangalore, Mumbai, right, or Delhi, you might have seen electric buses as well, right? So there are electric cycles, two buses, right? That's what is happening across the globe, and India is not an exception for that. Now, with this timeline understood, let me take you through the EV rebirth, right? So I'm going to now talk more on what is exactly the EV rebirth, right? So if I focus more on the EV rebirth, so let's say what did General Motors do, what Honda and Toyota did, right? And what exactly are uh, the efforts from Tesla, right? So let's have a look at it. So General Motors came up with EV1, which was, again, they manufactured it. It was a high performance vehicle, but there were a lot of limitations and they themselves stopped manufacturing that. But now you might have seen Chevrolet Spark and Chevrolet Bolt. They are available in electric version. And Chevrolet Bolt is one such benchmark vehicle from the giant automaker like a General Motors. But still, there are a lot of challenges involved. We will talk about it later. You might have heard of battery recall by Chevrolet Bolt, by General Motors for Chevrolet Bolt vehicle. Now, what happened to the next category of the company, for example, Toyota? Toyota earlier launched RAV4, that was a pure EV. But then Toyota interest got diverted into hybrid, and they came up with Prius and Camry, which is the hybrid electric version, and a fuel cell version as well, which is Toyota Mirai. So Toyota Prius and Camry are, I will say, most successful hybrid vehicles which are available nowadays. BZ4X is the only upcoming battery electric vehicle from the Toyota. So if you can see this and try to understand the strategy of the automakers. So the General Motors have only one model, let's say GM EV1, they stopped it, Chevrolet Spark, moving on to the Chevrolet Bolt, and a lot of challenges involved with that. Toyota diverting from the EV path at all and following the hybrid. And now they have only one model, BZ4X. So Honda and Toyota are following a similar path. If you take a look at what Honda is doing in this space, they are also believing more on hybrid and the fuel cell than pure electric vehicle, which are battery operated. Now, what Tesla did as a startup, Tesla came up as a company where they wanted to start from scratch and they don't want to become just an assembly company or I will say the manufacturing of the vehicle and they label the vehicle, right? But they wanted to become a technology company where they have the complete ownership of battery, motor, and the software, which is there in the vehicle. So Tesla is a startup, disrupted the market in the year 2008, and that's how the EV rebirth happened. Now, coming back to the present, what is the current market? What is happening now? So what is the state of art in hybrid and electric vehicle? So what is the reason why do we hear so much about EV and why EV is becoming now popular all of a sudden? Why there are a lot of news articles, why government is talking about it, why everybody around us who are interested in engineering, they are talking about electric vehicle. The very fundamental reason is it's very, very efficient. So electric vehicles are far efficient than the IC engine and it's going to become affordable as well. So if you replace something which is more efficient and affordable, that's going to disrupt the market. I'll give you a simple example. Let's say the LED lighting. So earlier, maybe 5-10 years back, the lighting which we see nowadays was very different than the previous, right? So let's say we were having a CFL bulb or the different type of lamp even were used for street lights, right? So the sodium lamp for street light you might have seen, or you might have seen a lot of different technology for lighting, which is CFL bulb, right? So now that CFL bulb was replaced with the LED because it was very, very efficient. It consumes less power and it is affordable as well. It is as equal the price of a CFL bulb. Now, that's the reason how the LED lighting disrupted the market, and uh, they came into existence. So similar thing happened with solar power generation technology, and the next is the electric vehicle. So let us talk about what each and every company is doing in India for electric and hybrid vehicle. So I will explain you in brief about what exactly is an hybrid vehicle, right? So you have a classical engine which is able to generate some power, and you have an electrical system where you have the battery and the electrical machine. Electrical machine can be either motor or a generator, and the combination of two can result into the better performance of the vehicle. Now that's what is called as a hybrid vehicle. And we are going to talk more about that in the next couple of slides. But what is happening across the various automakers in India? So Tata has came out of the era of just manufacturing Indica for passenger vehicles. So since 25, 30 years, they were only manufacturing, I will say, Indica, one version of the vehicle. Now they came up with a lot of vehicles which are more for passenger mobility. And let's say it might be Tiago, the Nexon, or Harrier, and a lot of other attractive vehicles, right? So Tata basically came out of the era of the Indica. They came up with new version, for example, Tiago here. What Maruti Suzuki is doing is they are doing the incremental changes. For example, here you can see the image of the Maruti Suzuki Ertiga. So Ertiga is now available in the smart hybrid technology, right? So there are two versions of the vehicle, which is the petrol or the diesel, and there is a hybrid version available as well. Now, the outsider company like Morris Garage came up with a pure EV, and they launched the pure electric vehicle as their first vehicle, and then followed by uh, the classical petrol diesel vehicles. So this is what is the state of the art for electric and hybrid electric vehicle. Now, let us understand, is the trend going to continue, and how fast the vehicles are going to get converted into electric vehicle. Now, there are two things. One, we need to understand what is going to be the penetration of hybrid vehicles and how much electric vehicles are going to get deployed. So this image or this bar graph is going to basically help you to understand more on are all vehicles, or typically the cars, we are talking here about only four-wheelers, are going to be electric. This bar graph basically explains how many percentage of the vehicle are of which fuel category. And here on the y-axis, what you see is number of four-wheelers across the globe, all countries included, in millions. So till 2015, we were having, let's say, around 87 millions of vehicles on road, and majority of them were petrol operated or gasoline based, which you can see in the dark blue color. The light blue is basically the diesel vehicles, and now you can see over the period of 2016, 2017, and 18, the petrol vehicle numbers have increased compared to the diesel vehicle. And the reasons are many, right? So now, talking about India itself, the government has imposed BS6 regulation, right? So that there are stringent regulations which are coming up. And now what you see in the orange and the red color, they are basically the hybrid and plug-in hybrid vehicles, and the red is basically the battery operated vehicle. So 2020 is the time where we can see 1% of the total four-wheelers across the world are electric. And you can see the 78% are basically the petrol, 14 are diesel, and there are mild hybrid and plug-in hybrid vehicles as well, which are respectively 1, 3, and 2%. Now, in the year 2023, where we are, the transition is taking place now. So we can see, let's say, the number of hybrid and electric vehicles are increasing day by day. By the year 2025, it is expected that we'll have a 6% deployment of the pure electric vehicles. Now, how this transition is going to take place? are we going to have only electric vehicles by the year 2030? The answer is no. We can't replace all the vehicles by electric vehicles. So whatever are the existing vehicles, they remain whatever fuel category they are. There may not be a very great retrofitment trend, right, where you convert your petrol and diesel vehicle to the electric one, which are existing. So you might have seen, let's say, converting into CNG kit, let's say with the help of CNG kit, converting your vehicle to a different fuel type. But here, the retrofitment for an electric vehicle is not going to work out. So in the long term, let's say by 2030, it is expected that around 15% of the vehicle will be battery electric. And how this transition is going to make, what are the factors that are changing the game over here, right? And because only the new type of the vehicle can be hybrid and electric, what are the reasons for this change to happen? So the initial reasons are the regulation driven. So let's say government is providing a lot of incentives. Government is having some restrictions over the classical vehicles because of the pollution constraint and all. And also, they are providing production linked incentives, and they are also considering, let's say, providing subsidy to the customers, right? And that's the reason how government is driving initially this change, where it's more regulation driven, right? So all governments, including India, they are pushing for the new technology and the better technology in order to reduce the carbon footprint. And is the government push going to survive forever? No, because it has to be the customers who has to realize the benefit of using electric vehicle. And therefore, this change is going to be the TCO driven. Now, let me tell you what is TCO. So the total cost of ownership is basically the kind of looking at the vehicle overall cost. So what basically I'm referring to is the total cost of ownership. So which means the cost of running the vehicle along with the cost of initial cost of the vehicle. So when you combine the ex-showroom price of the vehicle and you combine the per kilometer running cost of the vehicle, adding them together is going to be the overall cost of ownership of the vehicle through the entire life cycle or for the entire lifetime. And you may consider a battery replacement, or you may consider the resale price of the vehicle here as well. So because, as I said, electric vehicles are more energy efficient, I will say these vehicles are going to be more and more these vehicles, I will say, are going to be more and more affordable. And that's the reason why the customers themselves will create a lot of demand. And that's how the deployment of the electric vehicles are going to occur. Now, moving to why electric vehicles are costly, right? So if you do a basic total cost of ownership exercise and you try to understand that electric vehicles are really costly compared to the IC engine counterpart. So what is a real reason? So here, the manufacturing volume of the electric vehicles are really low. And if you manufacture anything, for example, a ball pen, right, just 5 pieces, then that 5 volume of the ball pen is going to cost really high. But at the same time, you manufacture it in thousands or lakhs of pieces, right? Then per quantity cost is going to come down a lot. And that's the reason why the electric vehicles are becoming costly nowadays. So the giant OEMs, let's say, for example, Maruti Suzuki or Toyota or Honda, they can't switch immediately to manufacture it. They can't stop manufacturing the petrol and diesel vehicle and can't switch immediately. And it's difficult for a small startups as well in order to manufacture in high volumes, right? So the relative volume of electric vehicles are very, very low. And that's the reason why it is high price. Now, if the price per vehicle, depending on the volume, because the volume is less and the price per vehicle is high, the customer is going to have restrictions, or let's say there will be a reluctance from the customer that they will not buy the electric vehicle unless and until they are convinced, right? So here, the customer demand is again the driving factor for the automakers to manufacture more, right? So if I am an automaker, I will see how many customers are asking for electric vehicle, and I will sell only that many electric vehicles, right? So for example, if I have to decide that how many vehicles I will manufacture which will be electric, then I need to look at the demand, right? So here we are stuck into a chicken and egg situation, where we don't know what is going to happen first, whether the demand is going to grow first. So whether more customers will be asking for electric vehicles and they are interested in buying electric vehicles, or the prices will come down with some magic that will happen. And then if the electric vehicles are more affordable, then naturally the customers will incline towards deploying electric vehicles. So that is the current situation, whether uh, the demand will grow or the price will come down. So here there are certain changes which are happening. Initially, let's say the government is helping in order to save on the taxes, in order to provide incentives to the production companies. They are offering subsidy to the buyers, but total cost of ownership in long term is going to survive the customer demand. So with this, I would like to take you through one such sample calculation of total cost of ownership. So what exactly is the costing or cost of running the vehicle, right? So if you kind of provide the data of how you are driving the vehicle, how much is your mileage of the vehicle, and if you have understood clearly the price of the fuel, right, per liter price of the fuel, and if you know how many kilometers that you run on a daily basis, and if you know the life cycle of your vehicle is, let's say, 7 years or 10 years, then you will be able to calculate easily how much is the cost involved in running the vehicle. So if you do such an activity, right, now, then you will be able to get the answer like, should I shift to electric vehicle, right? So let's consider a four-wheeler, and with the given range and the specifications, right? So let's say you are driving 50 kilometers daily, right? So you have a four-wheeler and 50 kilometers per day is your driving. So considering the approximate annual kilometers, right, that would be around 18,250. And now you consider the cost of charging the vehicle. And if you have a similar vehicle and if you are driving the petrol vehicle and you run the same number of kilometers with that, and you consider the petrol price to be around 100, and the fuel economy is, let's say, 15 kilometers per liter, how much is going to be the savings, right? So you can calculate the cost of running the vehicle with this simple calculator. And here with electric vehicle, you are going to have the cost of kilometer equivalent to 1 rupees, right? Even if you consider, let's say, the public charging, right, where you go and charge your four-wheeler at a charging station where you pay higher than the home charging, then the amount of saving that you will have, right, is approximately 1 lakh rupees a year. Now, when you are able to save 1 lakh rupees a year, assuming that you are driving 50 kilometers daily, it's a lot of saving, right? And maybe you can consider buying an electric vehicle which is costing 2 lakhs more than a petrol vehicle, right? So this is an example calculation, and I suggest you as a beginner person, you can figure out your own way of realizing. Let's say if you are a user of a two-wheeler, right? You can do a similar calculation and you can decide whether buying an electric two-wheeler is going to be economical for you or not. Now, This is the link which I will suggest you all to take a look and go through. Now, with the petrol vehicle initially becoming cheaper, right, and electric vehicle becoming the clear winner in terms of efficiency and the cost of running the vehicle, or the affordability, right, per kilometer affordability of an electric vehicle. Now, let us see the revolution, like what is happening with the engine, what is happening with hybrid and electric vehicle. So here I'm sharing a photograph of the engine which is used for a two-wheeler, right? And basically, uh, you must have observed this, right? So there are engines which are available uh, as a kickstart and electric start or auto start as well. So the motor and the battery basically help to start an engine. And almost all engines which are existing nowadays in the world, they are basically started with the electrical help. So by default, you have the motor and the battery associated with the engine. So here is a rear wheel drive of, let's say, similar to a vehicle which is Honda Activa, and you will be able to see, let's say, you can see the rear wheel uh, driven by the CVT over here. And that's where you have an engine basically receiving the fuel from the fuel tank and generating the torque which is required on the wheel. Now, if you take a closer look at the cut section, you will be able to see a small starter motor or integrated starter generator kind of a unit, which is actually helping the engine to start. Now, when battery and motor have been a very old friend of the engine, it's not just the battery and motor can help start the engine, they can share the load. And it is possible that more powerful battery and the motor can help reducing the load of an engine. And they can play an important role while the vehicle is running. Now, that means the hybrid vehicle. So let us understand the definition of a hybrid vehicle. Now, you might have seen i3S technology in the Hero, Destiny, and the Splendor two-wheeler. Uh, it's basically idle stop start, and it's also incorporated in the mild hybrid Maruti Suzuki Ertiga. And it's not that the battery and the motor will only help during starting the engine, but it will also provide more torque during the acceleration in the first gear. And it will also acquire back the energy when you apply the brakes. And that's how the mild hybrid vehicle works. So if I categorize the hybrid vehicle into three, there are major three categories: micro hybrid, mild hybrid, and the full hybrid, where let's say you have the engine start stop possible with the micro hybrid, and then slight regeneration and the motor assist during the first gear, that is also possible, or the low speed of the vehicle. But the micro hybrid vehicle cannot run the vehicle on its own completely, which means that if you do not have any fuel, or let's say if you do not have any help from the engine, you can't run the vehicle entirely on the electrical power. But in case of a full hybrid vehicle, that is possible. And it means that it is both electric and engine acting together. Now, let's check out what is happening with the Honda City Hybrid. And it's recently launched in India, and we are going to have a look at the website. So here is a Honda City Hybrid web page, and you can see almost the vehicle looks similar. There are a few design changes and the aesthetics, but it's a by default Honda City revamped version. But how the hybrid technology works, right? So let us take a look at it. So obviously the pricing is higher than its petrol version, but at the same time, the mileage that it offers is also higher. And that's the reason when I said hybrid are a better performance vehicle, instead of the Honda City, the petrol version, which can provide the peak value or the highest value of the mileage as 20 or 22, this is going to provide 27 kilometers per liter kind of a mileage. Now, let me take you through what is the technology behind it. So the hybrid version of the Honda City can run on 3 modes. So one is a simple mode where, let's say here, what you are able to see, the engine is basically helping to drive the wheels, right? So only the red part is coming into the picture, which is called as a engine driving. And this is basically the high speed highway driving. And engine through the clutch, through the transmission system is going to power the wheels. And this is called as an engine drive. Now, what is going to happen in the electric drive? So the blue color that you see below is basically the electric drive, or when you are running at a very less speed. So let's say you are in a traffic and let's say uh, its battery and the motor is capable of meeting the power requirement on wheels, then it's always better to use the more efficient source of energy, right? So the engine remains stopped here, and the power is given to the wheels through the traction motor from the battery. And that's how this is a pure electric vehicle drive, and it's kind of a casual city driving. So this is where your battery will get discharged. Now, what is going to happen in the hybrid mode, right? So if I go to the hybrid drive mode, it's basically the engine going to recharge the battery through the electrical generator, and it is going to basically power the wheels through the traction motor. So here you'll have two machines, one electrical machine acting as a generator and another one acting as a motor. So this is how the Honda City basically works. And let us get back to the presentation where I will show you the complete layout of Honda City Hybrid. So now here you can see the complete uh, architecture of the Honda City Hybrid, where you can see the intelligent power unit on the rear side, where it's a battery storage unit. And on the front, where you have the engine, which is basically the hybrid powertrain. Along with engine, you have the electrical motor and the generator as well. So you have a traction motor and the generator unit, which is basically part of the electrical CVT. And that's how it works together with, let's say, IV Tech standard engine. And that's how it's possible to run this vehicle in either hybrid mode, pure electric vehicle mode, or pure engine mode. So this is how the hybrid vehicle works. And moving forward, let's say, what are the challenges involved with the electric vehicle? So why companies like Toyota, Honda are not bullish on electric vehicle, and what is happening? So we see hardly 1 to 2% of the total vehicles which are electrified, and there are various reasons. So the first is the amount of energy it is having on board, which means the part of the vehicle, right? So very low amount of energy is there stored in the battery, and that is one of the challenge, right? So let's say you you refuel your petrol tank, probably you will be able to drive around more than 500 kilometers easily, right? And you get a lot of petrol stations for refuel, and it's just 2 or 3 minute stop, right? But in terms of electric vehicles, the amount of energy that the batteries are carrying is limited to 250 kilometers, 300. Some of the vehicles are exceptions, but this is the overall range per charge, right, of an electric vehicle. So another challenge is still under development and costly technology. So there are less volume of manufacturing, and the reason is the cost involved with the electric vehicles. And there are lack of infrastructure in terms of manufacturing the motor with permanent magnet, or having the ample amount of supply for the manufacturing cells which are used in the electric vehicle battery pack, or it may be the number of charging stations that you have. So there is a lack of infrastructure in all these aspects. And the service and maintenance is also one of the challenge involved over here. So these are a couple of reasons why we are restricted, but we are going to see very soon that how startups like Tesla is disrupting and how they are addressing all these challenges. So what is happening with the hybrid vehicles. So you will see companies like Volkswagen, Ford, Toyota, they are investing in the hybrid vehicle, and China is on their own way of self-regulation, where it's completely electric vehicle. And what is happening with India? So India has approved incentives in terms of electric and hybrid electric vehicles, and there are all automakers, right? So that not a single company is left now who is not developing electric and hybrid electric vehicles. So you might have some questions whether EV are going to have more deployment, or hybrid electric vehicles are also going to be part of the picture, right? So let us focus more on electric vehicles now onwards, and we will be talking more things about pure electric vehicles. Obviously, there are a lot of scope for hybrid electric vehicle as well. So let us talk about electrical technology, and let's talk about the things around us which are basically powered by the motor and operated from a battery, right? So let's say you might have seen Oral-B electric toothbrush. It has a single cell and a small motor. You might have seen a lot of hand tools which are battery operated, and there is a motor which is used to drill on the surface of a wall or any wooden material. And there are home appliances such as the vacuum cleaner. So this is a Dyson vacuum cleaner where it's a portable one. You can clean your terrace, you can clean your car. You just have to recharge this item. So the rechargeable components, including our cell phone, have been existing, but vehicle electrification is a real challenge because it's going to demand a lot of power, and it requires ample amount of energy on board. And it's not just running your laptop on a battery or having any electronic gadget, right, running on battery. It's all about moving the vehicle, which is kind of heavy. It has to attain a lot of speed, and it has to go through all environmental conditions, right? So, but we must have seen a lot of electric vehicles which are spatial vehicles. So the vehicle which are available in only electric version are electric wheelchair. You might not have seen any wheelchair which is basically operated from IC engine. You might not have seen any golf cart, or let's say aircraft towing vehicles are nowadays becoming electrified. And obviously the drones which can fly, no possibility where you can add an engine to it, right? And accurately control the RPM of an engine in order to change the position of the drone, right? So these are some of the spatial vehicles, but it's not only the spatial vehicles which are becoming electric. Starting from two-wheeler, three-wheeler, commercial vehicles, the waterways, right, where it's boat, yacht, or ship, they are also becoming electrified. And aircraft, helicopter, drone are also undergoing the electrification. So moving on with what is inside an electric vehicle. So I am going to now dive deep into the components of an electric vehicle. So what you can see over here is a rear-wheel drive electric vehicle similar to Tesla Model S. And on the rear axle that you have, which is responsible for driving wheels, is the traction motor. Now, traction motor is going to receive supply from the battery through the inverter. So the next unit to the traction motor is basically the motor controller, or so-called traction inverter. Now, this inverter is going to receive energy from the battery, and that's where you can see the traction battery pack on the bottom of the chassis. And this black colored battery pack is made up of many number of cells connected together in series and parallel. And we are going to talk about all the components in depth later on, but how this battery gets charged. So you need a charger. So you need basically onboard charger, for example, over here. So this onboard charger is basically receiving the AC supply from outlet and convert into DC supply, which is required to charge the battery. And then you will have a DC to DC converter for auxiliary. You will have a 12-volt battery to run and support all other auxiliaries. Here, the auxiliaries are basically the infotainment system, the cabin light, the HVAC, and so on. And you will also have the thermal system for cooling all these components. So you need to make sure the temperature of all these components, let it be charger or it might be battery or the motor, it has to maintain its temperature. And that's where you need a cooling system as well. So let us take the introduction of each and every component one after another. So basically the transmission system before coming between the motor and the wheel is the mechanical power delivered from the shaft of the motor to the wheels on the rear axle, as we have seen earlier. And the traction motor is basically the propulsion power unit, which is generating the motion from the electrical power. And inverter controller is basically changing the type of the power. So let's say what we receive from the battery is DC and what motor requires is AC. So therefore, it has to act as an inverter. And it controls power based on the throttle input received from the driver. Now, what is the important unit is the traction battery pack. It's basically the energy storage unit, and it's going to store the energy from the external electrical charging network. So onboard charger is basically the recharge of the traction battery pack from the AC power available in the network. Auxiliary battery is for supporting the low power loads other than the propulsion. DC to DC converter is basically connecting the high voltage DC system from the traction battery pack to the low voltage DC system. And then you have a thermal system or a cooling circuit, which is basically the temperature control, including the HVAC, which is for passenger as well. So basically, if you take a look at the development of a vehicle, right? Vehicle is an integration of multiple components or multiple parts. So the automotive parts, or you might have gone to, let's say, an automotive part supplier or a reseller, right? And you might have replaced your headlight bulb, or you might have replaced a 12-volt battery for your two-wheeler, right? Or you might have replaced a tire. So this vehicle is a complex integration of all the components, and that's where it requires a lot of engineering behind this, right? So how you match two components, and here is a photograph of an engine, right? So if you further take them apart, right? So a typical vehicle is made up of thousands of components, right? And integrating them all together, it's a really difficult task. So what usually automakers do and how Tesla did it in a different way, that's what we are going to discuss next. So what are the automotive industry segments, right? So let's say the company like Toyota, Mahindra, Tata, Honda, BMW, they are called as original equipment manufacturer or vehicle manufacturer. So the vehicle manufacturer, they do the assembly when they receive parts from their suppliers. So let's say the company like Tata will not manufacture the windshield glass, or the company like Tata will be using MRF or Apollo tire. Now that's where the supply chain comes into picture. So the company like Value, Continental, Bosch, they are going to supply automotive subsystems, right? So for example, let's say some company is going to give the entire infotainment system with GPS and telematics. Some of the company might be supplying the power steering unit. Another company might be supplying the engine control unit and the engine parts. And there might be some supplier for the sheet metal or the body in white of a vehicle. Now, tier 2 supplier is basically non-automotive graded parts, and basically they supply to tier 1 suppliers, right? So let's say when Bosch is going to do one integration at a subsystem level, they might get the raw material from tier 2, and tier 2 companies will get the raw material from tier 3. And these are the raw material. It might be engine oil, it might be the glass, it might be, let's say, iron ore, or let's say the raw material for steel, it might be steel scrap, or it might be the material which is used to manufacture the battery cell. So these are, this is what is the industry segment spread. Now, there are two design approaches. So the first approach is off-the-shelf components or being dependent on the suppliers. So let's say the companies like Maruti Suzuki, Tata, and few others, they are following this approach where they are dependent on the supplier to provide them the battery pack and the motors, right? So they do integration at a vehicle level. They rely on the quality suppliers. They save time and effort, and they will be able to launch the vehicle very quickly. And the engineers are supposed to choose the best compatible and cost-effective components. The other approach is developing the own components without relying on the suppliers, and therefore they become the owner of components and the vehicle. And this is how they will have the control over the quality, volume, cost, and the future upgrades, right? So that's the reason why uh, startups like Tesla have been doing this, and they have been more successful in terms of uh, doing in-house R&D and developing their own components. Obviously, when I say Tesla, they do not get into reinventing the wheel, which means, let's say, they do not actually manufacture the tire and process the rubber with the raw material, etc. Right? So they will have a lot of suppliers, but the key powertrain components like battery and motor and the relevant other components, they will have their in-house team developing this instead of being dependent on the other suppliers. And that's actually called as a vertical integration. We'll discuss that in detail in the next coming slides. So these are two different approaches which automakers have nowadays. And it's not only about approach A or approach B or the left side approach or the right side approach. There are a lot of companies which are following both the approaches, and they lie somewhere in the middle. And they follow, let's say, they take off the shelf components from some suppliers, and then they will develop something on their own, which are the remaining components. And that's the approach which is called as a combined approach, or I will say the integrated approach of off-the-shelf components as well as developing their own components. So another interesting thing that you need to know is, are EVs made from scratch, or are the electric vehicles uh, born unique, right? So there are two answers and both are correct. The answer is no, electric vehicles are not made from scratch, which means there are variant of the electric version which exist. So let's say, for example, Tata manufactures the vehicle Nexon, which is available in petrol and diesel variant along with electric vehicle, which means the mechanical platform remains the same. The look, feel, dimensions remains the same for Tata Nexon, whether it's either electric or petrol diesel, and many of the components will remain same other than the powertrain component. Similarly, Mahindra has a Verito which is coming up in diesel. It is also available in electric variant. But the answer is yes as well. And there are a couple of vehicles which are born electric, and they are new vehicle altogether. So they are mechanically redesigned, and their mechanical platform didn't exist previously. And their examples are Mahindra E2O and Tesla Model S. So this is an approach where you do not just retrofit the vehicle, but you design or redesign the mechanical aspects of the vehicle in such a way that they are more compatible with the electric powertrain. So let us take a look at what are the leading system providers. So nowadays, at vehicle level, you will have a vehicle manufacturing company. We have a lot of suppliers for electric powertrain and hybrid powertrain. For example, ZF, Borg Warner, Bosch, Schaeffler, to name a few. And there are battery suppliers as well. For example, Panasonic, Samsung, LG Chem, and BYD and Cattle. So There are system control suppliers as well, for example, Denso, Delphi, Bosch, and there are engineering service company, for example, FEB and EVL as well. So these are leading system providers which are nowadays available. But when Tesla did it uh, in 2008, many of the suppliers were not ready with their electrification components or with the electric powertrain components. And that's the reason how Tesla did it on their own. So what was the Tesla business plan? But before understanding the business plan, let us understand what basically Tesla is doing. So Tesla is a manufacturer of pure electric vehicle. They do not manufacture any vehicle which is hybrid or based on the IC engine. And they are into electric car, and nowadays you might have seen a lot of things. They are moving into the heavy commercial vehicles such as truck as well. So along with this, they are also into battery energy system, home to grid scale, and that's usually known as a Tesla Powerwall. And they are also into the business of solar panels and solar rooftop kind of integration, right? So this is kind of becoming completely independent in terms of carbon emissions, right? So Tesla believes into, let's say, not charging your EV battery from the conventional source, right, which is polluting the environment. So in order to have EV more cleaner and greener, you need to charge them with the electricity which is not produced in the power plant. And that's the reason why Tesla has entered into solar and the energy storage as well. So what is the Tesla business plan? So if you understand this image, so initially with the Tesla Roadster, Tesla targeted the super rich audience, where it was a high price, low volume production car. And that's where they get the recognition. That's where they reached out to the customer. They understood what exactly is the requirement. And therefore, initial level where the revenue, right, or the overall limitation on the utilization of the investment that they had, right? So they were able to manufacture very few vehicles, which are called as Roadster. But whatever they were able to generate the revenue, they utilized into the development of the next vehicle. And that's where the orange phase comes into picture. And when the orange phase comes into picture, where they were able to manufacture in higher volume compared to the Roadster in 2008. So they came up with Tesla Model S in 2012. Again, it was a high performance vehicle, but it was mediumly priced. It was less costly compared to the Roadster. But again, they were targeting the owners who want to get into the luxury cars. Now, whatever is the revenue generated in the step 2, they invested into the development of step 3. And step 3 is where it comes to the large number of vehicles, right? So the car manufactured for the mass market, right? So the common man's car, which can be electric, was the Tesla Model 3. Obviously, it's also high priced, but it was manufactured at a very large number. And nowadays, you can see there are a lot of interest with the Tesla electric vehicle. So this is the overall business plan of the Tesla, where they get started in 2008 and 2023 now. They are into a lot of electric vehicles, and to your surprise, Tesla is one of the top company in order to realize the highest profit per vehicle. And here they have overtaken Toyota as well. So Toyota have been into this industry for a long time, and they have been a major player. Even if you consider nowadays, the number of vehicles manufactured by Toyota are more than Tesla, but Tesla is able to achieve per vehicle profit, which is more than what Toyota is capable of achieving. And that's where you can see the success of the Tesla. So what are the technical specifications of the vehicle that Tesla released? So initially, the first generation of the Tesla Roadster in 2008 was having a lithium-ion battery made up of 18650 cells. At that time, these cells were manufactured in large volume, and they were used for uh, the consumer electronics. And because none of the cell was available, Tesla decided to use the similar cell, which was lithium manganese oxide kind of a chemistry. They used induction motor. Uh, it was a rear wheel drive, and they were able to get around 390 kilometers of range. In 2012, the Model S was bulky with a battery pack. It was 85 kilowatt hour lithium ion battery pack, and they were using uh, Panasonic cells, right? And we partnered with Panasonic in terms of supplying the lithium ion cell, again, using the similar induction motor and the rear wheel drive fashion. But now the range increased up to 500 kilometers. You will see Model X, Model 3 also came up with approximately 500 kilometers range. Now you can see 100 kilowatt hour of battery pack here. Model 3 is extremely optimized in terms of the energy usage. The similar, let's say 25 reduction in the capacity of the battery pack did not result a lot of reduction in the range, what you can see over here. And that's where they used a different type of a cell. They used a different type of a motor, which is more efficient. So they started using the permanent magnet motors from Model X and Model 3 onwards. So here, Model Y that you can see, these are the technical specifications, approximately the similar range. And now with the Cybertruck, they have a huge battery pack because it's a load carrying vehicle, and it has permanent magnet synchronous motor and 500 kilometers of range. So these are some of the Tesla vehicle specifications. Now, if we go into the detail of the batteries that have been used by Tesla. So 18650 is one of the popular form factor of the lithium battery cell. So they are basically the cylindrical cell, 18 mm diameter and 65 mm in length. So Tesla Roadster, Model S, and Model X were using this type of cell, and they eventually realized that it is possible to reduce the weight and increase the range of the battery with more safety. So the Model 3 was using 21700 form factor of cylindrical cell, and Model Y as well. 4680 is Model Y, which was launched, and this is kind of a cell which is, let's say, higher in volume and its dimensions, but produces more power and energy compared to its counterpart of the similar form factor 18650 and 21700. So this is what is the technological evolution that happened with Tesla vehicles. Now, Tesla also realized that it cannot be a completely dependence on the companies like Panasonic for the raw material of a battery pack such as cell. So they started developing their own cell chemistry, and the in-house cell 4680 is one of the benchmark that Tesla has created. And they have been using prismatic cell from the other supplier as well. So they are kind of having a mixed approach on having the cell manufactured at their gigafactory. Along with that, they are utilizing, or they are partnering with the cell suppliers such as CATL. So if you see the view of a Tesla battery pack, so this is basically the bottom of a chassis. And here you will see a lot of cells connected in series and parallel, and there are multiple modules. So here what you're able to see is one such module. So this much area which I'm highlighting is one module. And this one module is basically repeated all together, right? So this is kind of similar module repeated over here, and this all modules are connected in series. Now, each module is basically made up of small cells, and this small cells are basically kind of a cylindrical cell where it will look something like this. So this is what a cylindrical cell will look like, right? So it's similar to double A, triple A cell, which you have already seen in your TV remote control, right? But they are slightly different, heavy in terms of weight and slightly different in terms of dimension, but these are cylindrical cells. So with that, Tesla was capable having total 7,000 number of cells together. And this was a very complex engineering, or I will say integration, that they were able to do successfully. And this is where the safety comes into picture, the utilization of the energy comes into picture. And this is where, let's say, what will happen to the cells which are in the center part of the vehicle, their temperature goes above compared to the cells on the outside, right? And that's where they did complete thermal engineering in-house, and that was the reason why this battery pack became more successful. So each module has 6 number of cells in series and 72 number of cells in parallel, and there are 16 such battery modules. So in a way, there are 96 total number of cells in parallel, and that's how this battery pack will be approximately 400 volts in terms of the voltage level. So this is the nominal voltage. Obviously, the battery voltage will change based on its discharge and charge. So the nominal voltage will come out to be somewhere 345 volts. The fully charged battery voltage, if you consider 4 volts per cell, and there are 96 number of cells, it's approximately 390 volts. So this is what Tesla Model S battery pack was engineered. Now, Tesla quickly modified 18650 into 21700 and 4680, basically increasing the diameter and the length and putting more and more power into the cell, right? Where the power density of the 4680 is much, much higher than the 18650. And it's not just about the dimensions. They are working very deeper into changing the chemistry and ensuring that it is more safe. So typical Tesla innovations are basically kind of weight of the battery per cell, right, has increased. At the same time, the amount of energy it can store in terms of milliampere hours are also increasing. So this is what is happening in terms of battery. And you can see the minimum discharge voltage, the charge voltage, and whether they are manufacturing at the gigafactory or let's say there is an external supplier, they have been doing tremendous changes in terms of the batteries which are used for electric vehicles. So the major change that happened with 21700 and 4680 is basically the chemistry and the amount of power that they are able to package. So it's all about packaging, size, weight, and the number of cells that are required in a battery pack. So as we discussed initially, let's say one of the Tesla version of the vehicle was having 7,000 number of cells. Now it's really a challenge. So if the 7,000 can be reduced to, let's say, 3,500, right, by using a cell which is kind of having more capacity, then that was made possible with the help of 4680. So it's not just electrical technology that will account for, but Tesla did a lot of changes in terms of integrating the battery pack with the vehicle body, right? So they were able to increase the range. When you by default increase the range of your vehicle, you have more capacity of the battery, right? So when it, let's say you have more capacity of the battery, it results into higher weight of the overall vehicle, right? But Tesla was able to reduce the overall vehicle weight by 10%. And that's where they were able to get the opportunity to increase the range by 14%. And they were using 370 less number of parts compared to the previous design. And this is what was possible with the help of electromechanical engineers, how they were able to integrate uh, the battery pack with the vehicle body, and how we can do the light weighting of the vehicle. So this is what is an interesting thing to know about, let's say, how mechanical and electrical engineers work together in order to optimize the numbers. So it's not just the size and the chemistry and all, they also focused more on the cost as well. So let's say there are three different types of chemistry which are useful, right? So let's say $90 per kilowatt hour is a lithium iron phosphate, providing, let's say, 160 watt hours per kilogram. But Tesla is somewhere in the middle over here, where it's $130 per kilowatt hour, where it has more energy density, right? So this was the choice of Tesla in terms of manufacturing the battery chemistry, and even considering the safety and a lot of aspects, right? So here, this is the average cost, right? But when it comes to the higher quality of the battery pack, the choice is the main factor that the engineers have to rely on. So what is the kind of motor technology that goes inside the Tesla, right? So I'm going to quickly cover on, let's say, Tesla was kind of really independent on permanent magnet motors in the initial days. They were able to successfully deploy the standard three-phase induction motor, but it was completely redesigned for the application. So if you see typically 80 to 100 kilowatt of induction motor, right, it would be very large in terms of size. But Tesla redesigned it completely, and they were able to deploy the complex control of induction motor for electric vehicle. And after that, they also deployed interior permanent magnet synchronous motor, which is basically permanent magnet assisted AC motors. And that is where they were able to make motors more and more compact, and the control also become very easy compared to the induction motor. So the induction motor is kind of very challenging. You will see very few automakers will be using induction motor for the electric vehicle. But the real advantage of using the induction motor is simple in construction. It was easy to manufacture, and they were using, I will say, there are two types of motor, right? So based on the rotor construction, there are wound rotor motor, which are also known as a slip ring motor, as you can see over here, and the squirrel cage motor as well. So Tesla was using the simple construction squirrel cage induction motor, and that's where they were able to develop the required torque, and it was a high performance vehicle, and they were able to develop an induction motor which is compatible for the EV application. So the induction motor torque speed characteristics these are the natural characteristics, right? And it's not very easy to operate the entire vehicle in the full range, right? So usually electric vehicles will not have a complex transmission system. So instead of transmission system changing the speed and torque, here the motor controller changes the speed and torque required on the wheels. And for an induction motor with the natural characteristics, this is the only stable region. So the highlighted black is the only stable region. You can't operate basically the kind of electric vehicle in all the speed regions. So let's say starting from 0 speed to the stable speed. So this range was unaffected, right? Or this range is not possible if you do not use any motor controller. So the motor controller implementation in the low speed region was also the challenge, and Tesla was able to successfully overcome that. And that's how they use an induction motor with the multi characteristics with the variable voltage, variable frequency operation. And it was possible to successfully deploy with the electric vehicle. And another example is the interior permanent magnet synchronous reluctance motor. This is the construction of the rotor that you can see over here. And here, this type of a rotor is now capable of producing more torque with a less space. Now, that is possible by offering better reluctance and better allowing the magnetic field to flow, right? So this is kind of possible with a motor where, let's say, you have the magnetic field established more easily compared to the other orientation of the magnets in the rotor. And that is how basically Tesla is capable of getting the world best acceleration in terms of, let's say, 0 to 100 in 3 to 4 seconds, right? That's possible with the help of the motor, which is capable of developing a lot of torque instantaneously. So this is how Tesla have started using permanent magnet motors now. And one of the challenge that we have faced with the electric vehicle, and where a lot of companies, let's say General Motors, when came up with EV1, they were not focusing more on the charging infrastructure or how their customers are going to charge. But Tesla did it on their own, and they developed their charging network on their own. And this is where Tesla becoming more and more self-dependent and having more and more control over the customers. And one such thing is the charging network, right? So here you can see 2012, where there were only 7 supercharge stations operated by Tesla. 2022 is approximately 4,700 number of charging stations across the world. And that's where these are the charging stations where you can actually plan a road trip where, let's say, you have to stop and, let's say, get the top-up charge in just 20 minutes, right? So where, let's say, in 15 to 20 minutes, you can add the range as high as up to 320 kilometers. And that's where people were able to drive Tesla to, let's say, the long road trips, and that was never a constraint. So, and a number of charging stations over the period of time across Europe and other countries than US are also increasing. So the supercharge network is something which looks like this. This is where, let's say, one charging network will be approximately 1 megawatt of power, and it's a huge amount of power. So you can have 4 number of Tesla in the parking. You can easily charge them, right? And this is where the supercharger or a DC fast charger is going to add the top up to the vehicle. And Tesla also developed this technology in-house, and that's where they became independent. So there were no automakers who were talking about the standardized plug for charging. So let's say you want to charge your cell phone, right, or your laptop. You have a standard plug, right? So you can take supply from anywhere in the outlet. And in order to charge electric vehicle, there was no standard that were existing. So Tesla came up with their own type of plug. And here, nowadays, the new vehicle, the new version of the Tesla can be charged with the other charging stations where the type of the plug is CCS type 2, right? So it's a combined charging system. And let me show you more about the charger. So let me show you more about the charge connectors. So basically, Model S and X in China, they are having a GBT type 2, where the AC connector and the DC connectors are having this type of a pin outlet. North America, they have a TPC, which is Tesla proprietary connector. Europe, they are following TCS. They are following CCS, which is combined charging system. So here, basically, Tesla is following on their own in terms of charge connectors and the compatibility region-wise, geography-wise, and making the changes in the vehicle as required. So how Tesla became the game changer? This is an interesting thing to know. So usually what happens, let's say when Ford is releasing any new vehicle, or Toyota or uh, Honda is releasing any new vehicle, they will have a dealership distribution model, right? So there is a dealership network where they reach out to customer, right? And the automakers will be completely hidden, right? Or they will not be completely exposed to the customers. But Tesla did that in the other way around. And Tesla reached out to the customers directly, and they are kind of manufacturer of the vehicle as well as they are connected with the customers in terms of providing the service as well. So there was no spend on the advertisement. There was very minimum spend on marketing, etc. And they did independent production. They believed in creating the ecosystem, and there was no dealership and distribution network. And that's how they not only manufactured the vehicle, but they also went into the gigafactory. And they will have their shop where basically you go online and you customize your vehicle and you get the delivery, right? So, and when you want to get service, right? So then again, you have to go back to the Tesla without any dealership or without any third party involved. And that's where Tesla did it in a very different way compared to the conventional automakers. So what are the key technological developments apart from launching various vehicles? So the vehicle level integration, they did complete vertical integration themselves. They did vehicle development from scratch. Therefore, they were able to do the fast manufacturing the vehicles in a faster way. You might have seen a lot of things. Let's say when the Tesla Model 3 was launched at $35,000 US, there were a lot of people interested in, and there was a queue, right? So there was a huge waiting list, but Tesla was able to keep the promise somehow, where they were able to match the demand of the customers, and they did manufacturing in a different way. So the change management, let it be the software upgrade or anything, or it might be the autopilot, they did it in their own way. And there was an interdisciplinary approach. So not only mechanical design, electrical electronics, let it be the cell manufacturing, let it be the autopilot, let it be the different type of a vehicle, for example, Cybertruck, they did with the interdisciplinary approach. And that's where Tesla became the game changer. So is Tesla only the successful electric vehicle startup? No, there are a lot of other startups which are coming up. If you have seen in China, BYD is having more market share than Tesla. Then there are companies like XPeng coming in, and then there are companies like VinFast coming up from Vietnam, right? They are also into the electric vehicle. So there are a couple of unsolved problems at Tesla, and there are a lot of opportunities where Tesla can build more from here, right? So affordable and mass market EV products. So Tesla is still considered as a luxury vehicle. It's not a mass market product. For example, the electric vehicle from Nissan, which is popular, Nissan Leaf, is cheaper than the Tesla Model 3. Service and support is a challenge. Sometimes Tesla customers have to wait for 2 weeks in order to get their service done or any replacement of the part, right? Then charging infrastructure and the compatibility, again, Tesla is working hard on that. And high cost of the battery replacement. So let's say when you go with a very heavy battery pack, where let's say you get the range of 500 kilometers and more, it's really, really costly. Approximately 40% of the cost of the vehicle is there for the replacement of the battery pack. So these are still unsolved challenges where Tesla has already tried, let's say, swapping the battery pack. Tesla has already started with looking at the recycling of the battery pack and manufacturing the low-cost battery even for the replacement. So these are some of the unsolved problems that we can say. But yeah, Tesla is on the way in order to overcome all and achieve more. So how do I get started working on it? So let's say if you are a beginner level person, EV enthusiast, what you need to get done. So you need to focus on fundamental concepts. You need to have a domain knowledge of vehicle automotive systems and vehicle dynamics. You need to have thorough understanding of motors and power converters. You need to know battery technology, and not just the fundamental domain knowledge or theoretical knowledge on this is required, but you need to also have uh, knowledge on the software tools, right? So you need to get started with the software environment. You need to know how the software tool works in the background and how you translate a scenario into the simulation that you want to work on, right? So these are the things which are very, very important when you are at a beginner level. And how do you implement an idea and how do you interpret the results, right? That is more important, because there is a popular saying that the software tool is as powerful as the user. So if you are technically capable and you know how to use the tool, then only the software tool is going to help you in the project. So both subject fundamentals and the software tool knowledge is very much essential in order to you to get started into electric vehicles. Now, basically, how and why with the simulations, right? So simulations are very important. So mathematical models are most suitable for initial experiments. So let's say we want to have a new design of a motor, or we want to uh, put in more power with a new permanent magnet. Obviously, before it gets manufactured, you need to test it in the virtual environment in a computer, right? So that's what is a simulation. So simulation is basically helping to realize the actual system, right, by saving both cost and the time. Now, how the simulation works, so you have a physical experiments and you derive the governing equation, right? And those governing equations are basically your mathematical model, and simulation helps in solving that mathematical model with the help of governing equation. And that's how you get the results similar to the hardware, right? Or the actual implementation. So this is what is the power of a simulation. And as a beginner level engineer, you must uh, use a simulator in order to learn more. So what is the simulation approach for electric vehicle, and which are the tools which are popular in order to do the simulation for electric vehicle? So I'm going to list down some of the tools here. So in order to do system engineering, MATLAB Simulink, SimCenter, AmaZim, Ricardo Ignite. These are some of the example of doing system engineering for electric and hybrid electric vehicle. If you want to go with motor design, then the tools like ANSYS Maxwell and JMAG, they will be more popular for doing the finite element analysis. If you want to get into the power electronics or inverter development, then there are softwares like Power Simulator, PSIM, ORCAD, and Symmetrics. These are very popular in the industry for power electronics, DC-DC converter, DC to AC inverter, and the charger development. And then there are software tools which are used for doing the computational fluid dynamics, for example, ANSYS Fluent, COMSOL Multiphysics, and STAR CCM. So these are used for thermal management. So this is what all about simulation approach for electric vehicle. And let's say when it comes to testing, let's say the hardware in the loop testing by DSpace, Vector, Opal RT, the LabVIEW from National Instruments, and Chroma. These are very popular testing system providers for electric vehicle. Now, what is happening in India? So India, there are 63% of the companies which are focusing more on manufacturing two-wheelers and three-wheelers. And there are a few companies which are interested in four-wheelers and the other category of the vehicle, which can be commercial vehicle and the buses, etc. There are 8% of the companies which are working in the vehicle as a service or e-mobility as a service, where they are fleet operators or the self-driving rentals or ride-hailing services. Now, 20% of the companies are dive deeper into charge point operator or providing the charging infrastructure, and there are 5% companies which are into battery solutions, etc. So this is overall EV landscape. So the Indian automotive industry and the startups are really doing well. Let us have a look at the startups. So the EV startup space in India is also growing in the year 2020. These are the companies that were able to raise fund in millions of US dollars. So Ather, Blue Smart, companies like Euler Motors, Ola Electric, Ultraviolet, they were able to raise a lot of fund. Bounce Infinity is one such two-wheeler company. Charge Plus Zone is one such company, and there are new companies like EVH, Ultigreen, River, Yulu that are able to raise top 10 EV funding in India. And this is what is happening in India, and that's how, along with the major players like Tata, Mahindra, MG Motors, you are going to see a lot of startups coming in with the EV as well. So to summarize this talk, we have seen what Tesla was able to do compared to the mature automobile companies. And we also seen what is the vertical integration that Tesla was able to do, whether it's a motor technology, battery, or the software. And we also understood like how Tesla turned from just making a disruption to the profitable and sustainable company, right? And what was the business strategy behind that? And we also learned that simulation is the key to development and how you can get started about this. So, and another important thing is India is also following the global trend. So let it be China or US, where the companies like Tesla dominate. India is following the trend in terms of transitioning from IC engine to EV. Okay, so that's the end of the presentation. Thank you everyone for attending this session. I hope you learned a lot and you were able to get the key outcome in terms of EV technology and how Tesla became a successful automaker. Thanks a lot everyone for participating in this session. I will hand over this to Miloni now. Thank you very much everyone. Bye.
Thanks, Vatsal, for that very detailed presentation on the trends in the automobile industry and the fascinating deep dive into Tesla's growth and dominance that has in many ways changed the automotive landscape, even making the brand synonymous with electric vehicles. That's it from all of us in this workshop. Do check out our website, ET Career Ready, for more insights on learning programs, mentor classes, and skills that help you get future and career ready. But from all of us, goodbye.